It's Thursday, 22nd of January 2026, and welcome to the Water Action Platform. My name is Dr. Jo Burgess, and I have some delights in store. First of all, though, welcome to two sponsors. I want to celebrate Orange County Sanitation District. The eagle-eyed among you will have spotted their logo appeared in December. Welcome. And a warm welcome back to Halion. Both companies join us and these incredible organisations whose support of making best practice common practice is instrumental in everything we do. Many of them have been right here with us since the beginning. Thank you. You exemplified this month's theme, the innovation pipeline. Today, we're seeing how the water sector connects through the synergy of fundamental research, practical innovation, and field application. Just like these sponsors include research institutes, innovators, and practitioners. Our theme then is the innovation pipeline, and we're going to begin at the end, the reality of global operations, or science in the service of society. Last November, I interviewed Valerie Jenkinson, founder and chair of Operators Without Borders. Operators Without Borders is an NGO that sends skilled, qualified process operators into situations where they can help water utilities to achieve or restore smooth routine operations. Then, we heard from Mike Hewitt. As a volunteer with Operators Without Borders, Mike echoed Valerie's message that taking on this role changes your life. He said, supporting communities in disaster-stricken areas gives this work real purpose and shows how trained operators can make a direct impact. I then discovered that Mike was Operators Without Borders Volunteer of the Year. Well, I had to know more. What's it actually like to head into a disaster area? What kind of skills and experience make you a great volunteer? I had to find out. A little bit about Mike. What's your day job? And what on earth motivated you to volunteer for Operators Without Borders?
Great questions. I have been in the water industry since 2002. I started in Mississauga, Ontario. That's a region of Peel, fairly large plant, supplied water to 1 million people. And from there, in my 30s, I spent time overseas. I was in Afghanistan, Haiti, UAE, other things. I did actually get out of water for a time, for about 7 years, but I got back into it in 2015, and that was with Metro Vancouver. There's a water treatment plant there, another large installation, and I'm a certified level 4 in both water treatment and water distribution. And I had seen Operators Without Borders some years prior, but I started a company, Almaquin Enterprises, and we supply certified operators to small systems such as small communities, oil and gas camps, mining camps, also military installations. Okay. And as I was promoting Almaquin, I saw the work that Valerie was doing with Operators Without Borders, so I reached out to Valerie.
So for people that are not familiar with the Canadian system, what does a level 4 operator mean? Is that a particular number of years of experience or a skill level? Can you translate that for an international audience?
For sure, yes. So they're based on the California state certification levels, and they go through 1 through 4, with 1 being early stages and 4 being the highest level. Okay. And it's a combination of both experience, and you have to pass exams and demonstrate a certain number of what they call continuing education credits, CEUs, or units, I should say, rather. And once you get those 3 criteria, you have to pass the exam, you have to have a certain number of CEUs, and you have to have the years of experience. And at that point, then you go up a level of certification. And there's 4 disciplines. There's water treatment, water distribution, and on the wastewater side, there's wastewater treatment and wastewater collection. So there's Perfect. 4 disciplines in total.
Okay, that's quite a hard-hitting skill set, and you've worked in some really challenging environments, obviously.
Oh, yes.
Okay, so what did your onboarding as an Operators Without Borders volunteer entail?
So there was a questionnaire she's got on her website there. You click a link and that takes you fill in your experience, your education, what certification level you have. There's different policies for safeguarding, which is basically just measures to protect both the volunteers and the people that we interact with in the field. So filling out all that documentation and contact information, of course, next of kin, whatnot. And that way she has it all at her fingertips
So, your personal experience then, what kind of locations have you been to? And has it been man made emergencies, sort of post war zones or natural disasters, or some of each?
Um, I've been to two places so far with Operators Without Borders. I've been to Kenya. That was in a community called Nakuru, which is south or no, sorry, uh, it's west of the capital Nairobi. And there it was capacity strengthening. So it was providing a water distribution level one course to the operators at the utility. And we actually did a prep exam course and they wrote the exam.
Oh, wow.
So that was the first involvement I had overseas with Operators Without Borders. And earlier this year, I went to British Virgin Islands where we did some water distribution infrastructure assessments. And we were just finishing up a report. And there's actually a follow-up team that went and they began helping out with actually putting in the pipelines and correcting some repairs there. And there's probably gonna be some follow-on work in terms of training. And I've been also remotely assisted with a number of opportunities. One being there was a industrial wastewater study that looked at clean energy solutions for South Africa, Nigeria, and Kenya.
Okay.
And I also helped out with training program for Barbados and another one for Ghana.
Oh,
And
amazing. So these are really very different skill sets that you've been using. If we look at your two in-person volunteering stints, one is for capacity building, one is actually for emergency response. What does a day in the life of a volunteer on a mission like that look like? You know, do you get up at 5 a.m.? Do you have to sleep in a tent? Can you have a shower yourself? Is it 12-hour days? What kind of work do when you're doing these things? And who did you work with?
oh, for Kenya, they're both a little different just because of the nature of
Of
the work that
course.
was involved. Kenya was training, so in the evenings I was putting together the notes for the following day, the course I was going to instruct, and I went over with one other volunteer. He was teaching wastewater collection. I was teaching distribution. And so the day was in the classroom there, the utility. They had a bit of a boardroom they had set up for us. And we had the projectors and all the notes. And so we go over the course. So that was basically a 7 hour day.
Okay.
And then in the evening, we stayed at a hotel and put together the notes for the following day. So that was a great experience. We also took a day to visit the wastewater plant and another day to visit their water treatment facility. So we actually got to see what they were, and then it kind of was a role reversal because instead of us doing all the talking, they proudly were showing us all the stuff they were working on. It was very interesting to see.
Brilliant.
And then for the work that was done in British Virgin Islands, that was a bit different. We were looking at their infrastructure. They've got just some. They need some repair done to the system, and they've got a lot of non-revenue water. So it was a lot of I would say about 2 hours, a couple hours every day was meeting the folks in the office, discussing where we're going to go, what we're going to look at, and then we'd be about half day. Some days were a full day out in the field looking at the actual locations.
Yeah.
And so that would mainly being the pump stations and also the reservoirs. And then we'd usually come back to the office at the end of the day, gather our notes, talk to a few individuals. There was some debriefings that we would give to the director there. And we also participated in a press conference about midway through. So that was my first press
Amazing.
conference I've ever attended. That was very interesting. We formed the technical panel, and there was three of us, two Canadians and one American.
That
So,
really is in at the deep end.
oh, it
Fantastic.
was, yes, it was great.
What do you find the most satisfying? What part of volunteering for OWB is the best thing from your perspective? What's Mike's favorite thing?
Generates a lot of great experiences. You're out, you're sharing the knowledge that I've learned over the last 20 years. Um, and people are my experience has always been very positive. People are very receptive to the information. They love to talk, show you what they're working on and the problems they're experiencing, the challenges, and hopefully, and we can provide some guidance on some things that we know work for us, and we can share that knowledge and improve things. It's a real way to, well, it's two things. One, you get to explore the world a little bit more and see the globe, and also to help out with your fellow operators. It's fantastic.
Mike, thank you. What amazing experiences and what a skill set. Mike's company, Almaquin, deserves another mention here. Who better to help you achieve optimal water and wastewater management in even the most difficult locations? Mike's work with Operators Without Borders highlights the immediate critical need for technical expertise in regions facing infrastructure gaps or recovering from disaster. It's a reminder that water systems rely on the dedication of professionals who understand the ground level mechanics of distribution and treatment. But how do these mechanics evolve? Mike mentioned the importance of observing processes and documenting opportunities for improvement. When we take those field observations and apply decades of engineering refinement, we get the kind of technological evolution our next guest represents. We're moving now from the field to the facility, and for nearly 30 years, Rob Eden and the team at Organics have been refining how we handle one of the most persistent challenges in wastewater treatment: ammonia. They've moved beyond just removing it to destroy it, to a new era of turquoise ammonia, recovering a vital resource using renewable energy. Let's hear Rob's interview with Piers Clark on how Organics turned pollution control problem into a scalable recovery solution.
Rob, brilliant to connect with you. Now, we're going to jump straight in because I know that there's been a huge amount of interest in nutrient recovery and in particular around ammonia. So tell me, what is it that Organics Limited is doing on ammonia? And let's be clear here, this is about ammonia recovery, not ammonia removal.
Yes. Well, we've been removing ammonia from wastewater since 1997, when we built our first plant in Hong Kong. That was rated at 1,800 tons a day of wastewater. Since then, we've done 17 different plants in Hong Kong, and we've evolved. The technology has evolved, and the methods have evolved to the point where we are today, which we'll come into in a minute, I suppose.
Yeah, I think it's incredible that you've been doing this for almost 30 years. I mean, that's staggering. But that was the work you did in Hong Kong was initially on ammonia removal rather than recovery. Is that right?
Well, in actual fact, we recover the ammonia and we pass it into a thermal destructor and destroy it. So we recover it and destroy it on site. And the reason for that is there's no market for ammonia in Hong Kong, and really the waste management companies are not interested in going into the ammonia business. So they just want to get it out of the water and get rid of it.
Yeah, and of course that was the 1990s. Now we're in the 2020s, where green ammonia, as it were, or blue ammonia, I think some people call it, environmental ammonia, is much more attractive. So you've moved to developing a system that can now do ammonia recovery at scale at any wastewater treatment works around the world. Is that right?
Yes. We call it turquoise ammonia because it's not green ammonia. It's actually got two benefits. It's ammonia from wastewater, so it's pollution controlled, and it's using renewable energy, waste heat or waste biogas or whatever. So we call it turquoise.
Right. Now, for the technical people listening to this, and obviously keep it relatively high level, in 90 seconds, tell me, how does the process work?
Well, the big contribution that we've made is to use waste heat to free up the ammonia in the wastewater. So you start with the ammonium ion, which is NH4, and you convert it to NH3. As NH3, it's a gas, and you can blow it out of the wastewater. Historically, people have used pH adjustment to break that bond and release the gas. Whereas what we've developed is a method of using waste heat to break that bond and make the gas available for removal. One of the great, wonderful new innovations that we've come up with recently is that instead of using waste heat to run the plant, we're recycling heat. So that means we're taking the heat that's used at the outset and keeping it in the plant. So that means that we don't need to use waste heat or any heat at all. We can run the process with electricity just to keep the heat moving. So that is a scalable solution we can do from relatively small to very big. And we're quite hopeful that that's going to be an exciting breakthrough.
Piers, Rob, thank you. What Rob just described, the journey from a 1997 plant in Hong Kong to a modern, scalable resource recovery system, is exactly the kind of success story our industry needs more of. It proves that technological breakthroughs can transition from an exciting breakthrough into a global standard. However, as you'll know, that transition is not a straight line. There are thousands of brilliant ideas currently sitting in university laboratories that haven't made the jump to the commercial sector. This brings us to Marlene Su. As an innovation manager at ISLE, Marlene looks at the iceberg of water challenges, the aging infrastructure and climate impacts we see on the surface, and the technical and societal drivers below. In this mini lecture, she explains how university research and development can ensure the next 30 years of innovation are even more impactful than the last.
Marlene, thank you very much for joining us today. I saw your report for the University of New South Wales and I was captivated by your vision for research in the service of society. And I begged you to share your vision and passion with the audience here. You kindly agreed to give a 5-minute mini lecture. Are you set to do it?
I am, Jo. Thank you very much for that. I'm Marlene Su, Innovation Manager at ISLE. I work at the intersection of research, innovation, and real-world implementation in the water sector. My recent focus has been on accelerating the adoption of emerging technologies and shaping strategies and collaborative programs that address complex urban water challenges. Today's presentation unpacks the commercial and societal potential of UNSW's water-related research, positioning the tertiary sector as a key deliverer of global water sector innovation. We'll highlight some of the high potential opportunities and outline a strategic roadmap for translating these findings into high-impact commercial partnerships. Universities and research institutes have advanced the global water sector by bridging fundamental science with real-world solutions. Academic research pioneered membrane filtration for desalination, now deployed at scale in water-scarce regions including Australia, the Middle East, California, and Singapore. In recent years, universities have faced severe challenges. Funding cuts have reduced research infrastructure maintenance, talent attraction, and innovation support. In the UK, 50% of universities have closed courses, with 70% considering further reductions. The COVID-19 pandemic exacerbated these pressures through dramatic declines in international student intakes, a critical revenue stream. Australian universities lost 10% of their workforce and experienced a 40% drop in overseas enrolments between 2019 and 2022, severely limiting the sector's capacity to advance emerging technologies. The University of New South Wales in Sydney has conducted water research for over 75 years, establishing itself as a leading centre of expertise globally. It houses the Global Water Institute, one of Australia's most advanced water knowledge hubs with multidisciplinary reach across engineering, science, law, business, and social sciences. UNSW leads in water treatment research, wastewater reuse, stormwater harvesting, and nature-based solutions with work through its Water Research Centre and Laboratory, strengthening water security in Australia and worldwide. ISLE's engagement was to review UNSW's water-related R&D portfolio and identify capabilities for new partnerships or spin-out technologies. This wasn't the first time that we had done a piece of work like this, having delivered similar strategic mapping outcomes for water, utility, government and industry partners in the past. We drew on specialised literature and global water data to establish the overarching trends and drivers reshaping the sector. This was critically supplemented by utility discussions and input from our network of industry partners globally, ensuring the findings were grounded in real-world operational challenges and market needs. This dual approach allowed us to present a validated review of the trends influencing the future direction of water-related research. To illustrate this review, we used an iceberg metaphor to frame the global urban water challenges. The visible tip of the iceberg includes immediate threats like adapting to droughts and floods and replacing aging infrastructure. The vast majority, the below-the-surface segment, comprises interconnected drivers, severe climate impacts, resource scarcity, and technical and societal challenges of integrating smart asset management and digital solutions. Our review of UNSW's research revealed high potential expertise poised for commercialisation across 5 engineering schools: civil and environmental engineering, mechanical and manufacturing engineering, electrical and telecommunications engineering, chemical engineering, and minerals and energy resources engineering. We grouped these capabilities into 6 main areas. Key discoveries highlighted a strong alignment between UNSW's unique strengths, such as modelling and analysis of water movement through rock and other porous media, hydraulics, self-healing concrete, and advanced corrosion technologies, and the acute challenges faced by water utilities. UNSW also offers deep expertise in next-generation coastal solutions, working with the School of Biological and Environmental Sciences, advanced sensors for complex waters, and predictive digital twins for proactive asset management. Crucially, these capabilities possess significant cross-sector potential, supporting commercialisation via licensing, startups, and joint ventures with water-dependent industries. Strategically, working with water-adjacent industries offers traditionally water-focused businesses access to technological advancements, processes, or resources that can be found in other sectors. ISLE's work aims to draw out the unique strengths of individual clients. Our findings pointed to several high-potential themes for urban water sector: novel materials, eco-engineering, optimizing water treatment, net zero and resource optimization, asset performance and condition monitoring, as well as software applications in the water sector. Within these themes, we identified specific high-potential project areas. Strengthening partnerships with water utilities and water-dependent industries will reveal new segments and applications for industry-ready technology spin-outs, creating new commercialization pathways. Establishing new research partnerships in water-adjacent sectors also provides students with opportunities to undertake research that has real societal and environmental impact, helping them to graduate more workforce ready. Universities play a vital role in turning research into real-world impact, and there are several pathways through which this commercialization can occur. These include licensing, where intellectual property is granted to existing companies, startup creation, which builds new enterprises around university innovations, joint ventures, enabling collaborative projects with industry partners, and consulting or contract research, where academic expertise is applied directly to solve industry challenges. Together, these routes ensure that discoveries made in the tertiary sector are translated into practical solutions, driving innovation, economic growth, and societal benefit.
Marlene, that's absolutely fantastic. I love it. As someone whose PhD was done on a real problem for a water company, Yorkshire Water in the UK, and I could see at the end of 3 years the difference it made. That got me hooked on the idea of academic research for practical reasons. Nobody writes a thesis just to put it on a shelf. And I think what you said embodies the image of science in the service of the natural world and society. Thank you so much for sharing that with us.
No problem. It's my pleasure.
Marlene's strategic roadmap gives us a framework for how we take advanced research like modelling water movement in porous media or next-gen sensors and turn it into a commercial reality. It's about ensuring that the science in the service of society actually reaches the people who need it. And finally, I want to look at a project that embodies the very start of this journey. We're going to look at a research finding that feels like science fiction, but is grounded in elegant physics. Using a phenomenon called charge separation and a unique plug flow through millimetre-sized tubes, researchers have found a way to harvest energy directly from falling rain. Now, when we think about generating electricity from water, our minds go to the huge scale. Huge dams, roaring rivers, turbines inserted in municipal pipes. But what if we've been ignoring a source of power that just falls on our rooftops? Scientists at the National University of Singapore, led by Professor So, are challenging the idea that rain is just a product of the weather, to be managed by gutters and drains. They've identified that the kinetic energy of falling rain is largely wasted because we simply haven't had a system designed to harvest it until now. The core of their breakthrough isn't about spinning a turbine, it's about charge separation. When water flows over an electrically conductive surface, it naturally generates a charge. Think of it like static electricity, like rubbing a balloon on your hair. Positively charged protons stay in the liquid, while negatively charged electrons are donated to the surface. Now, historically, this has been incredibly inefficient. If you try to force water through tiny channels to increase the surface area, you spend more energy pumping the water than you get back in electricity. However, the Singapore team found a workaround using a 32-centimeter vertical tube and nothing but gravity. As droplets fall through the tube, they capture pockets of air, creating plug flow. This disjointed movement helps the electrical charges separate more efficiently as they travel, which are then harvested by wires at the top and the bottom of the tube, P1 at the bottom and P2 at the top. Now let's talk numbers. In their experiments, a single tube produced about 440 microwatts, and using a 4-tube setup, they were able to power 12 LED lights. While that sounds modest, the efficiency is the real story. The system converted over 10% of the falling water's energy into electricity, and that is 5 orders of magnitude more electricity than we've ever obtained from a continuous stream of water in a similar setup. The ultimate vision here is decentralized power. Imagine a future where this technology is integrated directly into houses or commercial buildings, providing a clean solution to renewable energy needs on a house-by-house basis. It's a brilliant reminder that in the water sector, even the smallest droplet can be a powerhouse of innovation. So the takeaway is clear. The pipeline from lab discovery to field application is what keeps our industry moving forward. Whether you're operating a system in the BVI or designing a new nutrient recovery process in a lab, your role is essential to this global innovation system. Thank you again to these amazing sponsors and role players in the water sector. Thank you to our guests for sharing their expertise, and thank you for joining us. Until next time, keep asking questions, keep sharing, and keep safe.